Okay, we're going to take a look at the red brake warning light circuit. So we're actually going to draw something on the board to show you what can turn the red brake light on, which again, a red light means danger. So it's usually things that you shouldn't continue to drive with because you could actually get hurt. So we're going to actually title this red brake warning light. And it's actually going to be the circuit. So we're going to actually draw an electrical circuit that's related to the red brake warning light. So first thing we're going to start with is the battery. Now the battery, again in a car, is around 12.6 volts DC. We're going to draw it as this symbol here. This actually represents the battery symbol. So if you ever see this drawn in a picture that you're looking at, this represents a battery. These are actually the cells in the battery, these long and short lines. This here is the negative side of the battery, and here's the positive side of the battery. The longer line here represents the positive side, and the shorter line represents the negative side. Now the negative side of the battery on a car is always connected to ground. That's the symbol for ground. This is anything metal in the car. It could be the fender, the frame, the engine, something that's conductive electricity. So I'm just going to label this ground. This is battery. This is going to have 12.6 volts with the engine not running, and it'll go up a little higher with the charging system working. Okay, after the battery, again, this is going to be an electrical circuit. So we're actually going to go through several different things. The first thing we run into is this component right here. And right now, that's actually an open switch. This is actually going to be our ignition switch. Ignition switch. So right now, with the switch in that position, it's open. If you turn the key to on, the switch is going to close. So right now your key is off and it's out of the ignition switch. If you have a car with a button instead of a switch with a key, the switch isn't being pushed in right now. So it's just sitting there. After the switch, we're going to have this component. Looks like this. Now this is actually what we call a fuse. Fuses are there to protect the circuit. So these are rated in different thicknesses. So some fuses rate at 10 amps of electricity, some are at 10, some are at 15, some are at 20. The higher the number, the more electricity can go through it before it burns open. So if something's wrong with the circuit after the fuse, instead of the wiring catching on fire, this will open up like this. And once that opens in the middle, it doesn't let any more electricity go through it anymore. So if you need to fix that, you need to put a new fuse in. So we'll be getting into fuses in the future, but we're gonna say this is a 20 amp fuse. And again, they come in different thicknesses depending on how many things are after the fuse. The engineers that designed your car figured out how big of a fuse they needed. Now in a house, they don't have fuses, they have circuit breakers. So if something goes wrong with a lamp or a light in the house, they don't burn open the fuse, they actually open up a switch, which is called a circuit breaker. And once you fix the problem, you can turn that back on and it will start again. They used to have these types of fuses in houses, but for the last 50 years, they've been using circuit breakers instead. Okay, after the fuse, we're gonna go into the light bulb. So right here, I'm gonna draw this. This is gonna represent the red light, the red brake light. Okay, so this is the light bulb right there. If electricity is flowing through this circuit from the battery, it will turn the light on. So right now the light isn't going to be on because this side of the circuit isn't going anywhere right now. If we did this, just to show you a quick circuit here, if I put a ground there and we have a ground over here, what this means is these two are connected together. So if you think about it, let's say we turn the key on, that would close this switch. Electricity would leave the battery, go through the closed switch, go through the fuse if it was good, go through the bulb, go to this ground. And because this ground is connected to this ground, all the electricity will get back to the negative side of the battery. That light will light up. Okay, if I open this switch up here, turn the key off, because there's no way for the electrons to get through the switch, it's going to stop flowing right there and the light will go off. If I turn the switch on, it'll close that. Let's say the fuse blows open, the light won't go on. If the fuse is okay, but let's say the bulb burns out, the light won't go on. Let's say this ground falls off because it's loose, the light won't light up. So all that has to work for the light to go on. All right, so now the way it works, we have three things that most cars have that turn the light on. Now, one of them is inside the master cylinder. A lot of cars have, again, this is our master cylinder. And right here, there's a little switch that's in the reservoir of the master cylinder. If you remember, this is full with brake fluid. If the brake fluid is full, it's going to be closer to the top of the reservoir here. As the fluid goes down, when it gets old, the level might drop to a lower level. If the level gets too low, there's a little switch here which will tell the light to come on, meaning you have low fluid level. So if your fluid's too low, it'll warn you by putting the red light on. Now, how does it do that? I'm gonna pop this switch out. It actually comes through the other side here. We're gonna pop it out. Okay, so this is actually what the switch looks like. And we're gonna actually test this. Let me show you how this works. I'm gonna draw a little picture up on the board. So basically inside this switch, we have two little metal terminals like this. And this is what comes out of the, so this is the connector right here. So there's two connections coming out of there. These two little metal connectors are inside here, but as you can see right now, they're not touching. What we're gonna do inside here, if I shake this, well, not this one, but can't hear it. Sometimes you'll hear a shake. It's actually a magnet that's inside the reservoir. I don't know why this one's not shaking, but what that is a magnet. So I'm gonna just put like a little magnet right here. North pole, south pole. Okay, that's a magnet. This is the fluid here. So what this magnet does is it floats in the fluid. And if the fluid's high enough, the magnet will be up far enough away from the little two terminals here, it'll keep them open. If the level drops though, what happens is these two terminals touch together, like that. So as the magnet level drops, it actually causes these two touch together, and that's actually gonna complete a circuit through this switch. Now we can test that. I'm gonna use this tool over here. I'll bring it over so you can look at it. This is our ohmmeter, so we're going to take a look over here now. So this is a tool that we've been talking about a little, a volt ohm meter, digital multimeter. So if we look closely, we're going to be setting it on this setting right here, which is the little omega symbol. Okay, so I'm going to turn this to that position, and you'll see on the display up here, it's going to read OL right now. Now the reason it's reading OL right now is because these two leads of the meter, these are the two red and black leads here, they aren't connected to anything. So right now, as you can see in the video here, that the two leads aren't touching. If I touch the two leads together, if you look at the display right now, you can see that it's reading OL. That's greater than 20 million ohms. That's a very high amount of resistance. If I touch the two leads together, you see how it drops pretty close to 0. It says 0.2. So you can see that. 0.2 is almost 0, and that's because I'm touching these two together. So this is an open circuit, which is greater than 20 million. This is a closed circuit, near zero. Now, if I take this switch here, that if I want to test this, I can take two jumper wires and put them inside the connector of the switch. So I'm going to put one inside here. If you look closely, can you see inside there? There's like two little metal things. Okay, one is going to go to one. And then the other one's going to go to the other one. You don't want them to touch together, though. You want them two separate jumpers going in there. Okay, so right now I just have two wires going into where the little terminals are there. I'm going to take these two ends and connect them to my meter. Now, right now, those two little terminals in there should be open. And right now, you can see with the meter, it's reading OL. That means those two metal terminals inside there are open. If I take this big magnet here and I get close to this, now what I can do is there's a little button right here that looks like a little sound wave. If I push that, when it closes, it'll make a noise. So see what happens when I get the magnet near it? So what's happening inside there, even though you can't see it, the two metal terminals in there are closing. They're touching each other. And that would be the same as if the fluid level went down in the master cylinder. The level would go down. And so picture this as the level of the fluid. This is floating in the fluid. When it gets close, it basically closes the switch. When the level comes up, it goes off. See how it's doing that? Okay, so all you would have to do to correct this problem would be to put more brake fluid in the master cylinder. All right, so if we take a look at where this is, so I'm going to erase that because that's just showing you what's going on inside there. We're going to take this circuit here. This is going to be that switch that goes to ground. This is our fluid level switch. Now, is this a normally open switch or a normally closed switch? It's normally open, isn't it? When there's no magnet near it, it's open. So I'm going to put N period, O period next to that. If you see that next to a switch, that means normally open. Now, when the magnet gets close to it, it's going to close those contacts. It's going to close the switch. Will that make a ground? Here's a ground symbol. So the other side of the switch is grounded. So think about this. If we turn the key on and this fuse is good and the bulb is good and this switch is closed, we'll have a ground here and that completes the circuit back to the battery. The light will light up. That's how they turn the light on when you have low fluid level. Now, if I put fluid in the master cylinder, the magnet will lift up, the switch will pop open. What will happen to the light? The light's going to go off. So that's how you can tell, basically, if you have your light on. First thing I would check is the fluid level in the master cylinder. Because if you have a little low level, and usually on the master cylinder, it'll have, right here it says add full. So these two little dots, if the fluid's down here, they want you to add fluid. If the fluid's up here, let's say you're looking through the plastic part, that means it's full. So being down here, way down here, will turn the light on because your level's so low that it's gonna be dangerous to drive the car. Okay, so this is one circuit. Then in branching off this one, we have another one. This is gonna be your parking brake. Parking brake. If you put your parking brake on, this is a switch. It's going to close this switch and it'll turn this red light on. So that's telling you have your parking brake on. Either you pulled the thing up or you stepped on the pedal on the floor and you park, put the brake on. This just tells you that the parking brake on. Some people will actually drive the car without turning that off. They don't realize they still have the parking brake on, which is bad. You're going to burn up your rear brakes if you drive like that. Okay, the third item that can turn on the red light is unequal pressure. So let's say we have This is at pressure. You see that okay?
Yep.
Pressure differential switch, DIFF switch. Pressure differential switch. That means you have difference in pressure from the front brakes to the rear brakes. How can that happen? Let's say you have a leak in your front brakes. There's fluid leaking. The pressure in your front wheels will be lower than your rear wheels because you have a leak. Think of a hose having a leak in it. Okay, that causes a switch to move inside this, and it will actually turn the red brake light on. How do you fix that? So this switch, all these switches are normally open switches. The only time they close is when your level is low, your parking brake is on, or you have unequal pressure because you have a leak somewhere. How do you fix the fluid level? You have to add fluid. That'll turn the light off. How do you fix the parking brake? You turn it off before you drive the car. That'll turn the red light off. How do you fix the pressure not being the same? You have to fix where the leak is. And then the switch will reopen after you fix the leak. Okay, so I just wanted to show you what the circuit looks like that turns the red brake warning light on. And again, this is just a typical switch that will actually, these switches here will tell you if you have a problem with your brakes. Any of these switches being closed is an indication that you shouldn't be driving the car because it's dangerous. That's why it's a red light. This is red. Red means danger. Do not drive the car. Fix the problem first. Low fluid, that's dangerous because maybe you have a leak and the fluid leaked out. If you have unequal pressure, that's dangerous. Maybe only your front wheels are working and your rear wheels aren't braking. And if you're driving with your parking brake on, you're actually burning up your rear brake shoes or brake pads because you're dragging them as you're driving. I've seen people have their wheels glowing orange because they were driving with the parking brake on. It can damage your brakes. Okay, that's basically it. We do have one diagram that I'm going to put in your module that looks like this. This is actually the diagram that we just drew on the board. This is from the service information on the computer. So this is similar to what I have up on the board. Okay, that's it.